math students. We're going to solve a problem today. The problem is going to be find all the zeros of this function using synthetic division or long division. For simplicity, I chose to use synthetic division. So, to begin, what we want to do is find a list of all the possible zeros of this function. We'll have a rational zero test. To have a rational zero test, we take this number here, 4, and we'll find all the factors of 4 over all the factors of 2. The factors of 4 are 1 and 4 and 2 and 2. Then also the factors of 2 are 1 and 2. And of course, we'll have a plus or minus for all these factors because it is a quadratic. The possible zeros come out to be plus or minus 1, which is 1 over 1, plus or minus 1 over 2, plus or minus 2, and then plus and minus 4. Moving on, we will now take our possible zeros and then place them into a synthetic division problem. So, our numbers here, we will first to start off, we'll choose -1. We'll just choose -1, knowing it works, but whatever you choose out of these possible zeros may not work for you. You have to do it until you come out with a 0 for your remainder. Having a 0 for your remainder will show that it is at a 0. So, synthetic division, we take our coefficients in this function, bring them down, like so, like we did. Now we will divide. So we're going to first start off by bringing our 2 down. So it is going to be 2 times -1 brings you to -2. You add these two together, this brings you to -7. -7 times -1, 7. -12 plus 7 gives you a -5. -1 times -5 gives you 5. 5 minus 1 gives you 4. Now 4 times -1 will then give you a -4, thus giving us a 0, which is what we're looking for. Now we have these values here will then bring us to a cubic function here. So we took our coefficients and then we placed our x's accordingly. Then we will have another synthetic division test with this cubic function. Bringing down our 2 times by 1/2, 1, -7 plus 1 is -6. -6 times 1/2, -3. 5 plus -3 gives you a -8. -8 times 1/2 gives you a -4. Voila, no remainder. Now, this is going to be in a quadratic state. Thus, now we can finally factor to find our zeros. So, doing like we did last time over here and bringing in our values and placing x accordingly, we're going to do the same thing here and place our x's accordingly. So, here is going to be our new function. This factors to be 2x minus 8, then x plus 1. This works because if you were to FOIL first, outer, inner, last, this expression, it'll then give you this. So, now that we have this here, 2x minus 8, we're going to set it equal to 0. Doing so, 2x minus 8 equals 0. We're going to add 8 to this side, and fundamentals of algebra, we're going to add 8 to the other side. Then we're going to do 2x equals 8. We're going to divide by 2 to get our x alone. 8 divided by 2 will then equal 4. So, we will do the same thing for our other factor. x plus 1 equals 0, minus 1 to this side, minus 1 over here on this side, x equals negative 1. So, finally we have our zeros. We have this expression factored all the way down to our zeros here. So, our actual real zeros for this problem are going to be 1/2, negative 1, 4, and also negative 1 appears twice. So, that is how you would do this problem. Thank you for your time. Thank you. So, also, looking at our problem here, we can also see that this function is going to have a maximum of 4 possible zeros.
Okay, solve by using the quadratic formula. We have the polynomial x squared plus 5x plus 9 equals 0. When you have a polynomial function that can't be factored, you need to use the quadratic formula. The quadratic formula is stated as negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Our a term is in front of the leading coefficient, our b term is the middle term, and our c term is the third term. So, since 5 is our b term, we have minus 5 plus or minus the square root of 5 squared minus 4 times 1, since that's the a term, times c. We put that all over 2a, since a is the 1. Then we multiply that out. 5 squared is equal to 25. Negative 4 times 1 is equal to negative 4, and we keep the 9 right there. And then 2 times 1 is 2. To simplify that further, negative 4 times 9 is equal to 36. And we have our 25, and we bring everything else down. 25 minus 36 is equal to negative 11. So we have negative 5 plus or minus the square root of negative 11 all over 2. Since we can't have a negative under the radical, and the radical being a square root, we replace the negative with an I. So then our final answer is negative 5 plus or minus the square root of 11 I over 2. Okay, so then our final answer is negative 5 plus or minus the square root of 11 times I over 2. I is an imaginary number because you can't have a negative under the radical.